right. I am going to reteach this in a much more simplified way. So when it comes to creating equations from graphs, we're going to keep it simple. When it comes with linear equations, you are going to start with point-slope form, and then you are going to solve for y so that your final answer is in this form, okay? You need a point in the slope. You replace the point with x1, y1, and then the slope, and then you just distribute and solve for y. All other equations, and that's why I notated f, because it doesn't matter what the function is. You have an a, and then you're going to have that shift, horizontal shift, left, right, and up and down. So you always want to take whatever that first parent point is and correspond that to the new starting point on your graph, which is going to be h and k. And so that's going to go directly into that equation. Then you use any other point in order to replace the x and the y, and you solve for a. So make sure you write this down. So let's take a look at how we are going to apply this to our graph right here. So the first thing that you want to do is establish the domain. So we've got three functions right here. We're going to start from -6 and we end at -3. Notice I'm including -6 because it's closed, and I don't have an equal to because -3 is open. The next portion goes from -3 to 1. Again, not including the -3, so I leave it, but it is including the 1, so I have an equal to 1. And then this next portion starts at 1, doesn't include it, and it goes all the way to 5, and it includes 5. Very important concept right now. If this were open, then I would have to get rid of that equal to sign. However, it is not possible for this to be closed and this one also to be closed, because it then would not be a function in which it wouldn't pass that horizontal line or the vertical line test. So very important that you can't have two domains that are going to two different functions where the x value is exactly the same. So you're either going to have one that's included and one that's not. So now let's take a look at the linear line right here. We need to find the slope. So the slope would, I could go up 2 over 1. So I know that the slope is 2, and then the point, I could use any point. I'm going to use -5, -3. And so when I do that, I'm going to take this information and I'm going to write it as m, which is 2, x minus -5, and then whatever my y value is. And now I'm just going to simplify that. I'm going to distribute. And then I am going to, again, simplify. So that is the equation of this line, 2x plus 7. Now, let's take a look and understand what's going on in this radical equation. First, we need to understand our parent of rad x, okay? You will notice that the parent starts at 0, 0, and the next point is very close to it, and that is the point 1, 1. And then the points get farther away. So we need to be able to establish the first 2 points on that radical. So if I were to take a look at this, I've got this open circle here. The very next point is very close to it, and then I get farther away. So what that tells me is the point that would correspond to 0, 0 is now going to correspond to negative 3, 1. That is going to be my H and my K because that's the original starting point. So if I were to take a look at this, okay, I've got y equals a. The function is the radical function, x minus h plus k. So my point 0, 0 corresponds to negative 3, 1, which is my h and my k. So that gives me y equals a, the square root of x minus negative 3 plus 1. So if I were to simplify that, I get y equals a and then x plus 3 plus 1. Now I use any other point to find the a value. I recommend finding that very next closest point. That closest point, which would have corresponded to 1, 1, now corresponds to negative 2, 0. So all I'm going to do is use this new point, negative 2, 0, and replace it with the x and the y. So the y in this case is 0. The x in this case is negative 2. I've got the plus 3 and the plus 1. So negative 2 plus 3 is 1. The square root of 1 is 1. 1 times a is a. And then I've got my plus 1. Subtract 1. I've got negative 1 is equal to a. Therefore, my new equation is y equals negative 1, the square root of x plus 3 plus 1. So now I'm going to take that and go negative the square root of x plus 3 plus 1. Now I'm going to do this again, but for the parabola. So notice the parabola. The point that corresponds to the parabola, let me just write the equation. So the point that corresponds to the typical 0, 0 is going to now become 3, 5. All right, so then that means on my new equation, I've got y is equal to a, x minus 3 squared plus 5. I'm going to use any point on the parabola very, very close to that vertex. And I'm going to use the point 2, 4. And I replace the y with 4, replace the x with 2, and then I just simplify. So I've got 2 minus 3 is negative 1 squared. So I've got 4 is equal to negative 1 squared is 1. 1 times a is a. Finish solving for a, and I get a is equal to negative 1. And then I'm going to come over here, write negative x minus 3 squared plus 5.